welcome to the data channel, and you're watching SQL Bootcamp for Data Professional. And as part of this topic 4, that is which is related to a SQL join. So, and we are presenting this particular video which details out the joins, multiple joins that you need to understand, and you need to know if you want when you are when you are in the journey of SQL learning, right? So learning SQL cannot be completed without learning joins, because if you take about any reporting, or if you take any real-time use cases where you are doing a data analysis, so definitely you need to write joins where you need to combine the data from different tables, right? And you need to have that relationship created so that you can get the data from multiple tables and do analysis and reporting. So it's quite important to understand what are the different types of join and how do we use it, and what exactly the importance of joins. So that also we will understand theoretically in this video. Before proceeding, if you're new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. Theoretically, basically, like SQL joins, right? You might be knowing that joins are basically essential in SQL because they allow us to combine the data from multiple tables into a single result set. So that is a basic definition of join. But so these joins will be majorly handy when you are working with a relational databases, typically in the normalized, meaning it's spread across multiple tables to reduce the redundancy and improve the data integrity, right? Basically, you have to come across the data normalization. Normalization means you have to split the data into multiple tables to avoid the redundancy, and even though you are avoiding a redundancy, you still need to combine the data. So that is where joins play an important role. And let us see one by one, right? So the data normalization and integrity, what that means. So normalization, basically, as you know, it's a process of organizing the data in database. Basically, you reduce the redundancy by normalizing the data. For example, there is a employee table, and in that employee table, you have a department column. So that department column, instead of having that column in the employee table, you create a separate department table, and you refer that with some primary key called a department ID or something, right? So that exactly one table is split into multiple tables by normalizing. So that is called as a normalization. However, when you do the normalization, the tables are split now, right? Once the tables are split, so if you want to get department details of a particular employee, definitely you need to join the employee table with the department table. So that is where so the joins are required, right? And next is complex query across multiple tables. This is obvious, right? So in the real time scenarios, in the real world scenarios, basically data is often spread across multiple tables and views, right? So without joins, it would be impossible to perform meaningful queries, and that requires pulling data from multiple tables. So that is where joins come in handy to write these complex queries to fetch data from multiple relational tables into a single query. So that as I said, like it might be just joining two tables, right? So it might be just joining the employee table uh, with the department table, right? Or it might be employee table, department table, and there might be a say there is a salary table. Okay, there is a performance related table, right? There is a location table. So basically you can understand, right? It becomes too complicated when, like, you kind of denormalize the table, or you can split the data into multiple across multiple tables. So to fetch any informations from which is spread across the different tables here, so definitely you need to perform a complex join. So suppose you want to get the few details from department table and details from the performance table, so then you have to join department table, employee table, and performance table, because there is no direct relationship between department and performance here, right? So that is how like joins comes in handy to kind of perform complex operations, right? And also like fetching row related data without duplication. So So by using joins, we can eliminate the redundancies. That is the whole purpose of normalization as well, and only fetch the related rows from different tables. Uh, this allows for more efficient data storage and retrieval compared to storing the redundant data in a single table. So that is what again it boils down to the same concept of normalization. And then we have a combining different data relationships. What that means is so the relationship might be different, right? The relationship might be often using a primary key and foreign key, but however, when you're combining those two tables, it can be it can be based on the different relationship where it is inner join you have to perform, left join, right join, full join. It depends on the relationship, like it's a one to one, one to many, many to many, right? So what kind of relationship do you have, as per the inner entity relationship diagram, right? So based on that, you will be able to understand what kind of join to be applied on like employee and location, employee and salary, employee and department. So what kind of joins you need to apply, so that speaks about that, right? And also like filtering and aggregating data across multiple tables. So there might be scenario where again you want to apply the filter, aggregate the data from multiple tables. So wherever the multiple tables come into picture, so then the joins will be there, right? So if you want to aggregate the data from multiple tables, because there are multiple tables involved, so there is no other way, we have to use joins here. So that is another use case, right? And finally, this is important where queries are used to joins are used to enhance the query performance also, right? So you might be wondering how joins can be used to enhance the query performance. Yeah, so instead of running multiple queries and processing the data in application layer, you can join, say, let's say, process data in the database itself, which is more optimized for handling large volume of data. So using a single SQL query with joins often result in faster and more efficient data retrieval than execute multiple queries, right? So that is why here you can write one query which is mapping all of these tables and retrieve the data, rather fetch this data individually and kind of combine them. So that way it becomes crucial to kind of like enhance the performance also. And in the cases of, like, say for example, you are using a self join kind of a scenario where it is again, yeah, it is a performance intensive job. However, like that is a best approach, instead of creating a new table, temporary table, and then joining the table with this table. So instead of that, so I think self join will kind of give more enhanced query performance, right? So now let's quickly jump to the practicals of it. We will understand how to create different kinds of join, what are the different kinds of join, all in detail. So to basically perform any join operation, you need tables, right? So if you're perform unless you're performing a self join, you need two or more tables. So if I want to perform any kind of joins, I will need some data and tables, right? Let me create two tables here. So one is a department table, and the another is employee table. And both, if you see, are linked with a foreign key. The employee table is referring to the department table using the foreign key called department ID. So this is referring to the departments via this department ID, which is a primary key in the department table. So once the table is created, so and now we will have to insert some values, right? So let's insert some values into this table. um, so there are four departments, and each department is having the ID. And whenever you want to refer to the department from the employee table, you refer using the ID. So one means HR and two means engineering or whatever, right? So let us try to execute this. And so now we have two tables, right? Let us refresh and see. So you have select the star department table, yeah, and you have select star from employee table. So if you query both, so you have the data in the both of the tables now. Okay. So in case, yeah, like if there is no manager ID, so that person is not having any manager. Okay. So this is about insert. So we saw the tables now, and let's kind of try to perform the inner join and see what exactly that looks like, right? So this is the inner join. So inner join, basically, what is the syntax, right? It is a inner join, right? That is the syntax: employee inner join department. So basically, when you're writing a query, there is something called as left table and right table. But when it is a inner join, or when it is a just full outer join, so that doesn't matter. But if it is a left join or right join, so then which table is at the left and which table is at the right will matter. But because we are using inner join, so it doesn't matter. But however, employee table is joining to the department table using inner join. So, and inner join is nothing but the particular key should be present in whatever the key that is used to join, right? That particular key should be present in both the tables, right? As you can see, like so the department is having 1 2 3 4, and actual employee table is having 1 2 3, basically 3, right? And so when you join these two tables, you are actually getting uh, like you need to perform inner join, because if you don't perform inner join here, so then what will happen, right? Let us see that. So if it is just a join, that is also a inner join. So if you're not specifying anything here, that is also a inner join. But if you specify left join or right join, so that will become let us see the difference now, right? Yeah. See, the difference is when you're performing left join, uh, what is there in the employee table is so the employee table is having this particular department ID null, right? But so when you try to map this department ID with the department table, so that gives you blank value. So the same blank value will be coming here. Okay. So even though there is no matching condition, even there is a department ID for this, but there is no matching condition. So even in that case, it will be right. So because a department, there is no department ID, something called as department ID null here. Okay. And even though, let us say I want to insert some value, let me try to insert some value here. Just for instance, say 106, where I that is 1, and department ID let me give as 10. Okay. So even in this case, what happens, right? Okay, there is a foreign key constraint because this 10 ID 10 doesn't exist in the department key, right? So that is a constraint. When you're entering, the department should be there. So that is why it maintains the data integrity for that matter, right? So coming back to the joins, right? Like suppose what we were seeing is the difference between inner join and left join. So here, if you see the inner join, what exactly it was doing is it will bring only the mapping matched conditions in from the both the tables, right? So if you see both the tables, which is the matching condition in both the tables, like with respect to department ID 1 2 2 3, these are present in department, right? So only those 1 2 2 3, that means HR, engineering and marketing. So only those has come here. That is the inner join. And even though if you don't specify anything, so that is also considered as a inner join even in that case. So that is why you see the same result. Okay. So the next thing is left join, where it will return the value even though there is no matching condition. Okay, but it will be null. As you can see, this value is null because there is no department ID for that value null here in this case, right? And here this matters, right? Like which is at the left side, so it will bring up all the columns from the right hand side, but basically returns all the records from the left table, like employee table, and only the matched record from the right table. Okay, so that is why left, it's called as a left join, because returning all the records from the left table, right? So that is why it is called as a left join. So if not found, so the right value will be marked as null, the department ID will be marked as null. So that's the difference of that. And left join is also called as left outer join, right? So inner join and outer join are different, right? Inner join is kind of a, if you know sets, right? So it's basically common value it takes, right? So here if you take left outer join and left join gives the same result in this case, okay? And so here what we are getting is all the employees even though without department with null of the department if not found. That's it, right? So now let's try to see what is right join. Okay. So right join is reverse of left join, right? So basically what you are saying is return everything from the departments. Okay, return everything from the department, but wherever it is not matching, for that you return null from the left hand table. But from the right hand side table, whatever you are getting, right, there should not be null, any nulls. Right hand side table, which is department, left hand side can be null in this case, because that is why it is a right join. So let us see this, right? So you have a employee table, you have a department table, right? But so this you are considering it as a right join. That is why, so all the records from the right hand side it has come, right? Like, because this is a main table, so main table Alice, Bob, Charlie, David is coming, right? But Eve is not there in the department table, so that is why we are marking it as null. Okay, but when it comes to the department table, so it is actually joining that with a sales table, and it is joining that with a department table, and it is returning say a value as a sales here, which logically is wrong, right? Because like logically you cannot return like name null and sales department, right? So that is where we need to understand whether it is a right join, left join, or which join you want to apply in a different case. So even in this case, if you consider, the most suitable is inner join, right? And in few cases you might still need a left join where you are okay in the report if the department is null, but still you want to get the name, right? So these are the important things: inner join, left join, and right join, right? So here you are getting all the employees even though without a department, with null for the department if not found, in case of left join. In case of right join, all the departments even those without null, with null for employees if not found. So that's the difference between left and right join, right? And next is, so these are the what I said is like this is left outer join and right outer join. So these are both are outer joins. There is something called as full outer join. Okay, so for full outer join, what you need to do is you have to specify full outer. So full outers will return all the records when there is a match in either of left or right. If no match found, null values will be returned for that particular, right? So let us see. This is a combination of left and right, basically, right? So that is why you are getting the records of all the six employees. So basically there were six employees, right? There were five employees, but the result you got is six. Okay, because so it is, what exactly it is doing is it is actually, when you do a full outer join, the record count is increasing because um, like for it is based on the department ID, right? So the first department ID is HR, so that is simple. For 2 it is engineering, that is also simple. For 3 it is marketing, that is also simple. But wherever it is not matching, so null is not matching, right? So then it uses left outer join and also the right outer join, so it will bring the combination of both in this case. And full outer join, because of the practical reason, it will not be much used, right? It is returning all employees and department, showing null where there is no match. So this kind of scenario is very rarely occurs in a real time cases where you apply a full outer join, right? So basically it is a combination of left outer join and right outer join. So you are getting a values from both the places, whether it is a null in the department table or whether it is a null in not found in the employee table. So for both of them you have a one entry each, right? So null is not found in the department table, but sales, so that is why you give the EVE and null, but sales is not found in the employee table, so that is why you are entering sales, and but then for the employee you are making it as null. So that is a full outer table, outer join table. So the next one is cross join. So this is also not much very frequently used, but let us understand what exactly it means. Um, yeah, it's just cross join, right? So it is throwing error, right? So saying that incorrect syntax near on. The reason is the syntax for cross join doesn't need any kind of keys here. So it just needs two tables. So table 1 and table 2. So based on the columns that you specify here, based on that it provides the Cartesian product. So of two tables, that is every row in the first table is paired with every other row in the second table. So this is practically this doesn't make any sense, right? In any cases, like but but yeah, if you have a use case where you want such details to be captured, definitely not in real time use cases where you're working with a large volume of data, and you need to be very careful when you're using cross join, because cross join will make the table huge, right? Because just if you just have a uh, records in one table as 10, in another table as 5, it become 10 into 5, 50, right? Because joins each records in one table with each record in other tables. So Alice is matched with all the HR department, right? So Alice is in engineering, Alice is in HR, Alice is in marketing. So similarly, Bob is in each department, Charlie is in each department. So which is logically doesn't make any sense, right? And also it will scale up the data like anything, and it might break the performance if you're working with a large table. So be careful when you're using cross joins, right? And every possible combination of employees and department is coming here regardless of the relationship between them. So there is no relationship here when it comes to cross join. So finally, we will see something called as self join. So self join is a regular one of a join where the table is self join itself. There is no two tables involved here, but so there is one table which is joined with the same table. Suppose, as you can see, the employee E1 is there and employee E2 is there. So E1 and E2 are getting joined here. Okay. So then you get the result. Basically, what we are trying to do here is so when you do a self join is to get the manager, right? Suppose like this is a famous um, scenario where you want to get a manager from an employee table for each employees. So where you need to perform a self join. So self join is again, as you can see, there is nothing syntactically changing here. So we are using inner join only. Self join, there is no like something called a self join, but it is the same inner join, but you are creating two instances of a same table here. Like one is employee, you're aliasing it as E1, another is employee, you're aliasing it as a E2. So E1 and E2 are getting joined with the employee and manager ID. So E1 dot name as employee will be there, and E2 dot name, that is which is coming from manager ID, so that comes from the other table. So the result, basically what will happen is for each person you are getting the, so if it is Alice, so it will go and check who is the manager. So there is no manager for Alice, it will skip. So for Bob, so it will go and check who is the manager, 101. So there is a person 101, so it will go and check it is Alice. And for Charlie it is again Alice. For David it is 102, 102 again it will go and check it is Bob. So basically what we are trying to do here is it's a self join, right? And to find the manager of each, and when you're displaying it, so first E1 is bringing you the name and the second is bringing you the name of the manager. So both the places you are bringing the name, but one is coming from E1, another is coming from E2, which is the same table but a different instance when you are joining, right? So basically these are the most common types of joins, and they help retrieve the meaningful relationship between the data across multiple tables in the databases. So hope this was useful. Please practice this, and if you have any questions, comment in the comment section, and also please like and subscribe for this channel, and thanks for watching.